We're now going to solve an equation, and we're going to demonstrate two different methods. Method 1 using a graph, method 2 doing it algebraically. So first of all, if we're going to draw the graph, we need to think like we did in the previous example and what transformations the 3 and the 5 would carry out. So the 3 would stretch the graph. In other words, it would stretch the original mod x graph, and that's what I'm going to sketch here, the original mod x graph. That would be stretched by a scale factor of 1/3 in the x direction, which looks like it's been squashed towards the y-axis with a scale factor of 3. And then the -5, well, we saw a similar thing in the previous example. That would move the graph to the right, not by 5, but by 5/3. And that's because of the stretch that's already taken place by a scale factor of 1/3, so it moved to the right by 5/3. So this graph would be less steep compared to the original mod x graph, and also move to the right by 5/3. I'm going to say there x is 5/3 here. Now how can we use that to solve the equation? Well, on the horizontal axis I've put x, and on the vertical axis I've put the modulus of 3x take 5. We want to know, where does the modulus of 3x take 5 equal 7? Let's draw a horizontal line this time. In fact, before I do that, I'm just going to work out where this goes through the vertical axis. So at this point here, we know x is 0. So if we substitute that in, we get the modulus of 0 take 5. So that's 5. So it goes through the vertical axis at 5. Now I'm going to draw a horizontal line where y is equal to 7. Of course, in this example, y is effectively 3x take 5. Sorry, the modulus of 3x take 5. So horizontal line there, y equals 7. And we can see there are two places where the graph of the modulus of 3x take 5 has a value of 7. One there and one there as well. Now, if you're going to use this method, the key next step is to identify the line segments or the parts of the graph and what their equations would have been without a modulus sign. So this line segment over here, that is the graph of y equals 3x take 5. Got a gradient of 3, and it'll go through the y-axis at -5 if it was allowed to continue. The other segment on the left, that is the graph of y equals minus, open brackets, 3x take 5, which if I expand the brackets, you might prefer it this way. This has a gradient of -3. You can see it's definitely sloping downhill, and it goes through the y-axis at 5. So in both these cases here, I'm thinking of y equals mx plus c to identify the gradient, which is m, and where it goes to the y-axis, which is c. So this segment is -3x plus 5. This segment over here is 3x take 5. So we now have a couple of equations to solve. If I call this solution here A, and this solution over here, let's call that B. So at A, the line segment we have is the line with a gradient of -3 and a y-intercept of 5. So that's -3x plus 5. It equals 7 at that point, has a y value of 7. So if we solve that, we get x is -2/3, which, looking at the graph, that does seem reasonable. We expected a negative x value, and we got one. That looks good. At B, the line segment where it reached the line y equals 7 was 3x take 5. And then solve where does that equal 7. This time x is 4. Again, looking at the graph, we expected a positive x value, and that's what we got. So we've solved the equation. We've got two solutions. X is -2/3, or x is 4. That's method 1, solving it graphically. Now please make sure you watch the whole of this video. It's useful to understand more than one method for solving a problem. So the second method, which is actually the one I would prefer, is an algebraic method. Now to do this, I'm going to say consider the modulus of question mark equals 7. What could the question mark be? Pause the video if you need to and have a think. What numbers could replace the question mark? Well, if the question mark was 7, then the equation works. If the question mark was -7, again, the equation works because the modulus of -7 is 7. So this question mark must be positive or negative 7. Let's apply that now to our equation. So if the modulus of 3x take 5 is 7, then the inside of the modulus must be either 7 or it must be -7. Now if we rearrange this equation, we get 3x is equal to 5 add 7 or 5 take away 7. So x is 5 add or take away 7 all divided by 3, which if we do those with the plus, we've got 5 plus 7, which is 12 divided by 3, which is 4. Or now do it with the minus. 5 take away 7 is -2 divided by 3 is -2/3. And of course we get the same answers as before, but I think that is a more efficient method, and that's the one I would recommend.